Okay, so we are learning about examining relationships, explanatory and response variables. So we have two kind of variables. One is called explanatory variable, which is denoted by X, and other is called response, which is denoted by Y. So now we will learn. Okay, so when we have to do the comparison of two populations of with the same variable, we either use side-by-side box plots or either we use back-to-back stem plots to make the comparisons. Often, however, we wish to examine relationship between several variables for the same population. When we are interested in examining the relationship between two variables, we may find ourselves in one of the two situations. We may simply be interested in the nature of the relationship. One of the variables may be thought to explain or cause change in the other. So these two things we will be interested either the nature or explaining the cause why the thing is changing. Okay. Does the caffeine in coffee really help keep you awake? Researchers interviewed 300 adults and asked them how many cups of coffee they drink on average day, as well as how many hours of sleep they get at night. The response variable Y is the hours of sleep, while explanatory variable X is the number of cups of coffee per day. So there are two kind of variables. One is a response variables and one is the explanatory variable. So what are they asking? They're asking they're asking about how many cups of coffee they drink. So they're asking about number of cups of coffee. So this is the explanatory. And what answer did they get? They get the answer that how many hours of sleep did they get or they don't get. So that is about the response variable and that is called Y. So these are the two variables. As are students who excel in English also good at mathematics or are most people strictly left or right brained? A psychology professor at a university locates 450 students who have taken the first introductory English course and the same math course and compares their percentage grades in the two courses at the end of the semester. In this case, there is no explanatory or response variables. So there is just grades of the student for English course and the maths course, and they're just doing a comparison between the grades. So there is no, they're not asking something, they're not giving any response. So there is no explanatory or no response variable. There's simply the nature of the relationship. Graphical displays. The best way to display the relationship between the two quantitative variables is with the scatter plot. A scatter plot displays the values of two different quantitative variables measured on the same individuals. The data for each individual appears as a single point on the scatter plot. If there is an explanatory and a response variable, they should be plotted on x and y axis. So explanatory variable will always be on the x axis and response will always be on the y axis. So in this way, we can plot a scatter plot. Consider a relationship between a country's fertility rate, average number of children per adult female, and life expectancy, average lifespan of its citizens. The table on the following page gives us the values of both variables. So there are two variables. One variable is the fertility rate and one is the life expectancy. So this is the scatter plot. What is a scatter plot? The fertility rate is 3.2, life expectancy is 62.5. So fertility rate is, if fertility rate is 3.2, life expectancy is 62.5, so we will put a dot over here. Similarly, we will put dot all over them and this is called a scatter plot. It's just putting the dot, not matching or drawing anything else. We look for four things when examining a scatter plot. Direction. In this case, there is a negative association between the two variables. An above average value of the fertility rate tends to be accompanied by a below average value of life expectancy and vice versa. If the pattern of points slopes upward from left and to right, we say there is a positive association. So what is the meaning of negative and positive association?
Uh,
The between the two variables, there is a negative association in the scatter plot that is mentioned above. Why?
yeah.
because the above average value of fertility rate tends to be accompanied by below average value. So the plot is going in this direction like this. So this is a negative association. But if it's vice versa, the pattern of point slopes upwards from left to right. If it is vice versa, then it would going to be a positive association. So the shape of the points also tell us about the association of the direction of the graph. Form. A straight line would do a fairly good job approximating the relationship between the two variables. It is therefore not unreasonable to assume that these two variables share a linear relationship. What is a linear? Linear means drawing a straight line. So linear relationship, there should be a straight line. Strength. A strength of the relationship is determined by how close the points lie to a simple form such as a straight line. In our example, if we draw a line which roughly approximates the relationship between the two variables, all points will lie quite close to the line. As such, the linear relationship is quite strong. Strength. Not all relationships are linear in form. They can be quadratic, logarithmic, or exponential, to name a few. Sometimes the points appear to be randomly scattered, in which case many of them will fall far from a line used to be approximating. In this case, we say the linear relationship between the two variables is weak. Outliers. There are several types of outliers for bivariate data. An observation may be outlying in either x or y direction. Another type of outlier occurs when observation simply falls outside the general pattern of the points, even if it is extreme in either x or y directions. Some type of outliers have more of an impact of our analysis than we will discuss shortly. Okay, so now the main thing they're telling about is the linear relationship. What is the linear relationship? That if we draw a line over here matching a few points and all of the other points lie very close to the line, then it means that if we draw a line, then this is called a linear relationship, if we can draw a line. And if all other points are very close to that line, then it means that the linear relationship is very strong. The strength is good and the linear relationship is strong. So it's not necessary that always we can draw lines. Sometimes there can be a curve, quadratic graph like this. Sometimes there can be a linear, logarithmic, or exponential graph. So also. The scatter plot shows a moderately strong positive linear relationship. Why it is strong? Because we can draw a linear, because we can almost just match these points and draw a line, and all other points are very close to the line. So whenever we can draw a line and all other points are close to the line, so it means the linear graph is very strong, or the linear relationship is very strong. Does the relationship for the data in the following scatter plot appear strong? So yes, it do appear strong. In the same data, the scales are different. Okay.
Yeah.
This example shows that our eyes are not the best tools to assess the strength of the between the two variables. Can we find a numerical measure? So obviously our eyes are not best to examine. Our eyes can just only give an approximate value, but it cannot be exact. So obviously we're going to go for a numerical measure. The measure we're going to use to find out that about the strength of the linear relationship is called correlation. So what is correlation? Correlation are measures the direction and strength of a linear relationship given between two quantitative variables. So we already know what is a quantitative variable that has some quantity. So when there are two quantitative variables and we need to measure the direction and strength. Two things. One is direction, second is strength. We use correlation that is denoted by R. Suppose the values of two quantitative variables x and y are being measured for n individuals, then correlation is given by 1 over n minus 1 sx xy summation x minus x bar y minus y bar. Now this formula is very easy. And is total number of items. X is standard deviation for x values. Sy is standard deviation for y values. X bar is mean for x values and y bar is mean for y values. So everything you know, you already know how to calculate means and standard deviation, so you can find the correlation easily. For fertility rate and life expectancy example, we have. So I'm going to write them over here. It would be like this. I will write them. X bar is 3.05. They have already calculated X bar for you. It's 3.05. Y bar is 65.6. SX यानी कि standard deviation for X values is 1.60 and standard deviation for Y values is
11.20.
11.13. So these four values are given to you and you have to find the correlation. So these values I have written for you, and I am moving to the slide number 19 so that because you might not know the formula yet. So this is the formula. So just do the calculations by putting the values in this formula and you will get the answer for the correlation. The formula is also written over here. This is the same one, yes. Are you doing the calculations?
Yeah.
Okay.
What N would be total
N would be total number and it should be given to, let's see. For the fertility and life expectancy, X bar, Y bar, S6 and SY is given what about N? Yes, we can count him from here. 1, 2, 3, 4, 5, 6, 7, 8. Should be 8.
X? Do I multiply it?
Yes, yes. Now you have to multiply.
That's 6.828.
Great. Oh my God. 6.828 is the final answer. There is some mistake. It's not only 1 in the numerator. Wait a minute. Let me do it for you. Okay. It's not only 1 in the numerator. What is happening in the formula is, see, this is the formula. So it says summation x minus x bar. So it means you have to write here summation. What is xi? Xi minus x bar, yi minus y bar. So you have to take the sum of these two columns too. First of all, you will multiply the two columns and then take the sum of the two columns. But for that, you need to plot the data. Okay, let's do it. First of all, you have the values of xi and you have the values of yi, okay? So you know
Mm-hmm.
what is x bar. So you do xi minus x bar, you get this column, yi minus y bar, you get this column. When you multiply both the columns, you get the last column. After multiplying it, you add them. After adding them, you now put them everything in the formula. Xi minus x bar, this sum, minus 120.56 in the numerator, denominator, and you will get the answer. Not yet we calculate R directly in the Microsoft Excel. Okay, association versus causation. We must be careful when interpreting correlation. Despite the very strong negative correlation, we cannot conclude that having more children causes a short life expectancy. There are many other variables that could help explain the strong relationship between fertility rate and life expectancy. One other variable is the wealth of a country. Association versus causation. Women in richer industrialized countries tend to have fewer children than women in the poor third world countries. We also know that life expectancy is higher in rich countries because of better healthcare, education resources, etc. The wealth of the country is in this example is known as lurking variable. A lurking variable is one that helps explain the relationship between variables in a study, but which is not itself included in the study. So the study that we were doing is about life expectancy and the number of children. So in this, there is a third variable which is not directly involved but do have some effect on that relation. So that third variable is known as lurking variable.
Okay.
Association versus causation. Regardless of the existence of identifiable lurking variables, we must remember that correlation measures only the linear association between two quantitative variables. It gives no information about the causal nature. So obviously, this is a numerical association, numerical value. So it is only going to give us the linear association. It is not going to tell us about the nature of the relationship, that how the relationship is. Some properties of correlation. Positive values of R indicate a positive association and negative values indicate a negative association. If R falls between -1 and 1 inclusive, values of R close to -1 or 1 indicate a strong linear association. A correlation of -1 or 1 is obtained only in this case of a perfect linear relationship. When all points fall on a straight line, values of R close to 0 indicate a weak linear relationship. So what are they saying? If the values of R are positive, it's positive association. If they are negative, it's negative association. Number 1 point. Second, if it's between -1 and 1 inclusive, values of R falls between -1 and 1 inclusive. Values of R close to -1 or 1 inclusive, strong linear association. If a correlation of -1 or 1 is obtained only in the case of a perfect linear relationship when all points fall on the straight line. So if the values of the R are close to the 0, it indicates a weak linear relationship. So if it's between -1 or 1, then it means it's very strong. If it exactly -1 or 1, then it means it's a very strong straight line, like it's 100% straight line. And if it is close to 0, it means it's a very weak relationship. So these points we should remember. You can write down somewhere and you should remember these points for the correlation. Okay, next is some properties of correlation. R has no units, so R is a correlation and it has no units. The correlation makes no distinction between X and Y. As such, an explanatory and response variables are not necessary. Changing the units of X and Y has no effect on the correlation. It doesn't matter if we measure a variable in pounds or kilograms because R has no units, so changing the units won't affect the value of the relationship. Some properties of correlation are measures only the strength of the linear relationship. So we have already studied it so many times that R is a correlation that only measures the strength. It does not tell about the nature of the relationship. Because the correlation is a function of several measures that are affected by outliers, R is itself strongly affected by outliers. Okay. So we have already studied something about, remember we studied that median is not affected by outliers. Mean is affected by outliers. So similarly, R is also affected by outliers.
Yeah.
Any question up till now?
No.
We have completed. Okay. So now we're going to start regression. We have already done correlation. What is regression? When a relationship appears to be linear in nature, we often wish to estimate the relationship between variables with a straight line. A regression line is a straight line that describes how a response variable y changes as an explanatory variable x changes. This line is often used to predict the values of y for given values of x. So we have already learned that we have two kinds of variables. One is called response variable and one is called explanatory variable. Right? So we have two variables, explanatory variable and response variable. So what is regression? Regression will tell us what are the changes coming in the response variable in contrast to the explanatory variable. So it will tell us the changes or the comparison between the two variables. Okay, note that with a correlation, we didn't require a response variable and an explanatory variable. Usually in regression, when we have explanatory variable x and a response variable y, but this need not to be in the case. Given a value of x, we would like to predict the corresponding value of y. Unless there is a perfect relationship, we won't know the exact value of y because y is a variable, so definitely we should know the relationship. We will use a sample to estimate the true relationship between the two variables. Our estimate of the true line is y hat is equal to b naught plus b1x. So now this is the relationship between the two variables. What are the two variables? X and y. The two variables are x and y, and the relationship between the two variables is called regression. And that relationship is y hat is equal to b naught plus b1x. Now, what is y hat? It is a predicted value of y for a given value of x. Because we don't know what is the value of y, we know the values of x. So y hat is a predicted value of y. B naught is the intercept of the line. What is the intercept of the line? Intercept of the line is also called the slope of the line. And
Okay.
B1 is the slope of the line. Okay. Now let's do some questions so we will know it. We would like to find the line that fits our data the best. That is, we need to find the appropriate values of V0 and V1. But there are infinitely many possible lines. Which one is best line? Since we are using X to predict Y, we would like the line to lie as close to the points as possible in the vertical direction. Now we have already plotted the scatter plot. We have already made the scatter plot, but we don't know which line is best fit for our data. So now we have to find which line is best for our data, and this to find this line we're going to use regression. The line we will use is the line that minimizes the sum of square deviations in the vertical direction. Least square regression. The values of b0 and b1 that gives us the line that minimizes the sum of square deviations are b1 is equal to r sy over xx, b0 is equal to y bar minus b1 x bar. Now take a moment and write the three formulas. This one, and this one.
Okay.
Write down three of them, then we will move on.
Done.
Least square regression. The slope of the regression line B1 is defined as a predicted increase in the y when x increases by 1 unit. So what is the slope of the regression line? Slope of the regression line is B1 delta y over delta x. It means delta y over delta x. Increase in the y values when x increases. So as the x increases, what is the increase in the y values? That is called the slope. Slope is always increase in the y with respect to increase in the x. So what is intercept? The intercept of the regression line B naught is defined as a predicted value of y when x is equal to 0. So when x is equal to 0, what is the value of y? That value is called the intercept value of. Some variables in y is accounted for by the fact that as x changes is pulled y along with it. The remaining variation is accounted by for other factors. The value of r square has a special meaning in least square regression. It is a fraction of variable in y that is accounted by for its regression in x. Okay, let's take the example. If r, now these are the very important points. If r is equal to -1 or 1 and r square is equal to 1, obviously if r is equal to -1, what is r square is equal to 1. If r is equal to 1, r square is equal to 1. In both the cases, r square is equal to 1. That is, we can predict y exactly for any value of x, as iteration on x accounts for all the variations in y. If r is equal to 0, then r square is 0. So regression on x tells us nothing about the value of y. So otherwise, r square is between 0 and 1. So what is the value of r square? This is always between 0 and 1. So this is an important point that r square is always between 0 and 1. You can write it somewhere. Okay, now what is this example saying? Fishermen are concerned that the pollution from a pulp and paper plant near a river is contaminating the river's fish with mercury, which makes the fish unsafe to eat. They would like to use the age of a fish to predict the mercury concentration in the system. The age of a fish is a good predictor for mercury concentration, as older a fish have been exposed to the mercury longer and will have higher level of contamination. It is impossible to measure the age of the fish. So it is decided that the length of the fish will be used as the explanatory variable, as length and the ages are highly correlated. So we don't know what is the age of the fish. This is a fish and we don't know what is the age of this fish. But we know the length of this. We can measure the length of the fish, for example, 5 inches. So we know that the age of the fish and the length of the fish are correlated. Correlated means they're related to each other. How they're correlated? Because as the fish age increases, the fish length also increases. So we can measure the length of the fish and that will give us a predicted value of the age of the fish.
Okay.
Sample of fish will be taken from the river and a regression will be run to predict mercury concentration of fish that will caught in the future. This must be done because the fish cannot be sold or eaten after it has been tested for mercury. So obviously if there is a contamination, we cannot salt the fish or eat the fish. So how much the contamination is, we will just take the fish, measure its age using this length, and then we will